I said, baka, like a chicken.
No, I hear that.
Bak, bak, baka.
Note that.
I hope you recorded that.
I did. For all your viewing pleasures. Listening pleasures. Can't view it. All right, well, yeah. Anyways, nonetheless. All right, so the first one, the very first thing we have to do is what?
0.
Set equal to 0. So we're going to get 9x squared plus 12x plus 4 equals 0. And then we'll always check if we can factor. Right? So, what times what equals 36? What plus what equals 12? What are you going to get?
66.
Aha. Aha. Voila. Very good. 9x squared plus 6x plus 6x plus 4. We have to do decomp. Like I said, if you don't know how to do decomp, admit it sometime. Okay, take a 3x out, and we're left with 3x plus 2. And then we take out a... That's me. I'm blowing my nose right now. And then we take out a what? A 2. Therefore, no one knows any difference in YouTube land. So we have 3x plus 2.
Yeah.
Wait a second. We have 2 answers. Shh. They're exactly the same.
Wow.
Holy smoker doodles, Batman. 2 that are the same. Oh my goodness. So we're going to go 3x minus 2 equals 0. We're going to add 2. And we get 3x equals 2. And divide by 3. We're going to get x equals 2/3. Why did we get 2 that are the same? What happens when we get 2 that are the same?
It was a positive, and then it was a negative.
Oh, I thought I got it wrong. I had this one.
I fixed the problem. I have no idea what you're talking about. Yeah?
Because the x-intercept's on 0.
The x-intercept's on 0, but why is there 2? Yeah. Yep. Because the vertex is on 0. Whenever the vertex lands on the x-axis, we get 2 that are the exact same. And they happen to actually be the vertex. Oh my goodness. Winning. Okay. So if we want to, that would be solving, we'd be done. X equals negative 2/3. If I wanted as x-intercepts, you would say negative 2/3 and what? 0. Another word for x-intercept is? Yeah, zeros. And another word? Roots. And what we would actually say is that our x-intercept is this multiplicity 2. Leading you into next year. Multiplicity 2. Multiplicity 2 just means there's 2 of them.
Why you said there's 2?
Because in math they say multiplicity 2. You're on my list. Just kidding. What are you going to do if there's 2 of them? You're
You
going to
just
say
say there's 2 of them.
well, you can do that, but what you actually have to write is multiplicity 2, so it won't work out well for you. But you can do whatever you want. I won't stop. All right. Now, this one we have to add the 6 over and add the 1. 3x squared plus 6x plus 1 equals 0. And then we try and factor. Something multiplies to give me 3 and add 2. Oh, it's never going to happen. Not going to happen. So this is my A, this is my B, this is my C. X equals negative B, which is 6, plus or minus the square root of 6 squared minus 4 times 3 times 1, all over 2 times 3. So x equals negative 6 plus or minus 36 minus 12, which is 24, over 6. So x equals negative 6 plus or minus, what can 24 break down into? 4 and 6. The 4 comes out and it's a 2. So I'm going to get plus or minus 2 root 6 over 6. Am I done? No. It's a 3-for-1 special, right? The 3-for-1 special. So if you can take something out of all 3 of them, you do. If you can't, you don't. You're done. But I can, so I'm not done. I can take a 2 out of this one, and I get negative 3. When you're taking it out, it's division. 2 divided by 2 is 1. 6 divided by 2 is 3. So we're going to get x equals negative 3 plus or minus root 6 all over 3. How many different answers is that? 2. Now, that's exact values, correct? And if I want exact values, you stop, you box, you move on. We agree? Can I check it though? Yeah? So, to check it, you are going to write check so that I know that you know you're checking it and not giving me an actual answer. To check it, we're going to have to turn it into decimals. And we're going to have to go to our calculator and find the decimals and hope the decimals match. We agree? So we're going to check it. So we're going to go x equals -3 plus root 6 all over 3. And x is going to equal what? I didn't let you do this, so I'm reading that. Where? What did you get? -3 plus root 6, enter, divided by 3. Make sure you put this in fractions, or you do the top, enter, divided by the bottom. We get negative 0.18 approximately. Approximately. So that's not exact, right? I rounded that. That's not an exact decimal. It's a rounded decimal, opposite of exact. But for checking, it's okay. And then I go -3 minus root 6 all over 3. Everyone should be typing this in because so many people get this wrong because they can't type it into their calculator correct. So type it in until you get the answer I have. Yep. You're right. Now once you have those, type your equation into your y equals. What was the equation again? 3x squared plus 6x plus 1. Type that into your y equals. You have it in your y equals? And try and find the zeros. Go. Second trace 0, left bound, right bound, enter. Everyone doing it. So we're type in 3x squared plus 6x plus 1. So 6 is your standard window. So go second trace 0, which is number 2. And then I always start on the very far left and just go left, right, and then I never do it wrong. So I start on the far left, enter. Then I go past the x-intercept, enter. And then you see it's on both sides of the x-intercept, enter. So I get -1.87. Oh! Girl, please. It matches. Oh my goodness. Oh my goodness. Now if we want it on our main screen, we can go x-enter, and there it is. Remember, we can pull it up onto our main screen. Then second trace, number 2. On the left of that x-intercept, on the right of that x-intercept, enter. Something is wrong with this one, Karsten. This should be -0? No, it says it's not -1, is it? Why is it not? It looks like a 0 on here. Oh, it's the other one. Yeah, okay. See, -1.81's this one, and then it gave me -0.8. It's the other one. I'm just stunned. It's fine. Yep. So you get the other two. Did you get them? They matched? You know, you're right. Are these the actual answers I want, though? No, because I want exact values, so I want this. Right? Okay. So in the last unit, quadratic equations, we solved by factoring. We solved by quadratic formula. We solved using our calculator, finding all the x-intercepts that way, right? And we also did discriminants and natures of roots, didn't we? Okay, so we're going to go over those ones tomorrow. Can I get you to open up your notes because we're going to do multiplying and dividing radicals. So We have multiplying and dividing radicals. So when we added and subtracted, we had to simplify every radical first, and then we could only add and subtract radicals with the same radicand. Yeah, I did say radicals very clearly. McKenna's just giggling. I sounded like I was trying to say it in an accent. All right.
I thought you just said that. Which one is it?
Yeah, I'm really confused. You just said that you can multiply
any of them.
You can add and subtract, is what I'm saying.
Oh, I think it's multiply. I was like, oh.
Nope. So you can add and subtract, I'm going over yesterday's stuff, radicals with only the same radicands, correct? So our first step when adding and subtracting radicals is to reduce them, to simplify them, so that we can make them the same so we can add and subtract them. You agree? Multiplying has nothing to do with that. So you only can add and subtract the same radicals, which is the same rule as integers. So for example, if I had 3x plus 6, could I do anything with that? No, because 3x and 6 are not like, correct? But if I had 3x plus 4x, could I do anything with that? 3x plus 4x? Yeah, it would be 7x, because they're like terms, correct? Same thing with radicals. They have the same radicands in order to add them. But if I had 3x times 2, can I multiply those? 3x times 2 is 6x. Do they have to be the same in order to multiply them? No, neither do radicals. Okay? So, multiplying radicals. Multiply the coefficients and multiply the radicands. You can only multiply radicals if they have the same index. That's the only catch. So you can't multiply like a square root by a cube root. Okay? It has to be a square root times a square root or a cube root times a cube root. Okay? If the index is even, you have to state the restrictions in the radicand if it has a variable underneath it. If there's a letter under the radical, you have to state the restrictions because it can't be negative. When multiplying radicals with more than one term, use the distributive property. So we're using grade 10, foiling, distribution of polynomials, all that stuff. Coming back today. Okay? So, we're going to go over some basic ones first. We'll do a little warm-up. What's root 2 times root 2? It's root 4. Because we multiply what's in front by what's in front. Yeah. Patience, dear Watson. Patience. So, we have a 1 in front and a 1 in front, correct? So when you do radicals, which these ones are easier, doesn't matter, we're doing the rules, still same rules. What's in front times what's in front, so 1 times 1 is 1. Do I have to show that though? No, I'm just proving a point. And then square root 2 times square root 2, you multiply the radicands together. So what's 2 times 2? And what do you get then? 2. Okay, let's see. Wait a second. Root 2 times root 2 is 2. Okay. Let's try the next one. Root 3 times root 3 is root what? 9. Because it's 3 times 3, right? And what's the square root of 9? 3. Okay. Root 3 times root 3 is 3. Root 2 times root 2 is 2. Root x times root x is root x squared, which is x. So root x times root x is just x. Huh. Can we make a rule here?
Everything is the last one.
Everything in the thing is the last one. Solid rule. Yep, I think we should write that down. I think everyone will know. Everything in the thing is the thing. You knew exactly what you were saying.
I did.
I know. And you had a rule. But it was just quite comical because, yeah. But you knew exactly, and I gotcha. I gotcha.
I didn't know that.
So, the rule actually in layman's terms is when you multiply two roots together that are the exact same, you get that answer.
Damn, that's what's up.
So if you, root A, Shmalab, times root A, it's just going to be what?
Root A. It's A.
That is not the rule. A. Root 6 times root 6 is? Shh. Root 6 times root 6 is 6. Root 4 times root 4 is 4. Because you just make these numbers squared under a square root, which cancels the squared and square root off. Technically, root 6 times root 6 is actually root 6 squared. These cancel, so I'm left with just 6. So whenever you multiply two roots together that are the same, you get just the answer without the radical. So like root smiley face times root smiley face would equal smiley face. Now with the cubic, what do you think you have to do in order to get just the answer out?
Just
You have to be able to cube root it, so you need to be able to have, instead of have 2 of the same number, you have to have 3. Oh, look here. Isn't that a miracle? Cube root of 5 times cube root of 5 times cube root of 5 is the cube root of 25, or 125, sorry, which is also the same as saying the cube root of 5 cubed, because it's just 5 3 times, right? Technically, it's 5 3 times just 5 cubed. And what does the cube root and the cube do? They cancel, so it's 5. So if you have a cube on the root, you have to have 3 of the same. So a rule would be like the cube root of A times the cube root of A. Can I get an answer from that? No. But the cube root of A times the cube root of A times the cube root of A is just A.
Yeah.
Yep.
So if you did have 2, would that be the cube root of a squared?
Yeah, and you just sit there. Nothing else. Could do nothing. It'd be
Very
boring.
nice.
We're not done. That was the warm up. Okay, now that we're warmed up, let's go to the next page.
Really grasps that.
Okay, so here it says task 1, multiply. Express each answer as a mixed radical in simplest form. So first you have to multiply it, then we're going to have to simplify it, and then that's it. The only thing we're learning here, new, is front number, multiply. Radicand, radicand, multiply. That's the only thing that's new. Then we dig into the deep, dark depths of grade 10 and we reduce. Okay? So the new math in grade 11 for radicals is the easy part. Then we always end reducing from grade 10. Okay? So let's look at this. 6 times 2 is 12. So coefficient times coefficient. Coefficients of the numbers in front. And then radicand times radicand. 5 times 3 is 15. Then, that's the grade 11 part. You're welcome. Now that the grade 10 part comes in, can I reduce 15? No. Box it. Okay, the next one. I can either choose to reduce them first or reduce them after. It doesn't really matter. You can simplify first or simplify after. But I'm going to simplify after just for now. Then I'll show you how I do it if I simplify first. So I go coefficient times coefficient. So this can be the one way I can do it or the other way. I'm going to show you 2 ways. So I'm going to go 1/3 times 1, which is 1/3. Then square root 45 times 10 is 450. Can I reduce 450
yes.
into what?
225, which is 15.
What?
Or is it 16?
225?
225.
Okay. 225 is a perfect square. It's the square of
15 or 16?
15. So we can go equals 1/3, 225 times 2. The 225 comes out and it's a 15. And what do I do with these two numbers in front? Multiply. What's 15 times 1/3? It's 5. Root 2.
That's that.
Or we could have reduced the 45 right away. So what is this 45 reduced to? If I go 1/3 root 45, it breaks down into 9 and 5. The 9 comes out and it's a 3, which is 3 times 1/3 is actually just 1, root 5. So this would be 1 root 5 times 1 root 10, which is 1 root 50. And then root 50 breaks down into 25 and 2.
Wait, so which one's right? Because if you have to have most.
Which one's
simplified
right?
4, you have to simplify the 45 first, right? Oh wait, what? Definitely.
Silly as hell.
Oh, it's something.
That is silly.
Apparently. So,
Well, you wrote 1 root 5 and you just exploded my brain.
well, 1 root 5 is up here.
Well,
So 1/3, and 45 breaks down into 9 and 5. The 9 comes out and is 3. 1/3 times 3 is 1 root 5. And then you can multiply them. I personally, if you're okay with dealing with really large square roots sometimes, like off the chart, it's a lot of the time it's easier to just, or less steps, to just multiply, reduce after. So that's the option I usually pick. But like this one, I could reduce this into 4 and 7 first, right? And then go and multiply it after. So you could reduce them first, then multiply, or just multiply, then reduce, which I'm going to do. But then you're dealing with larger square roots. So, coefficient times coefficient. 3 times 1/4. 3/4. And this equals this. So I put equal signs down the left-hand side. And then I go square root. What's 28 times 14?
196 times 2.
What is it?
Oh, I didn't know this.
He's working ahead. 300 and what? Thank you. Then 392 breaks into what perfect squares? Remember, you want to have your perfect square chart beside you.
2 and 196.
The chart wasn't up here, guys. I don't know what you think I'm erasing. I was erasing like grade 12 stuff.
I have a chart written down.
What does that
That was like 1.2.
Oh, it means factorial.
No cap.
Like it sounds like it's screaming 8. Yeah. Okay. Make yourself a chart in front of your face so that it's not just Riley giving the answer.
I like when Riley gives the answer.
Riley's not with you on the test.
Yeah, he is.
No,
I
he's not.
forget, Caleb, he's carried your practice.
13 is 169. 14 is, what was it again?
96.
15
Maybe
is
there's like
225.
15 is 225. 16 is 289.
Where's the goal?
I don't know.
Something like that. I stop at 15 in my head.
17 is 300 and something. 343 is that. Is it 334?
Oh, wait, no, it's pattern 3/4.
I think so.
How long are we going?
256?
That's what we got, yeah.
They had the whole time. I have no idea what you're talking about.
289 is 17.
I don't know what you're talking about. I have everything right.
20 squared is 4 squared. I got that one.
Yeah, we're good with that.
You just messed up your art. 18 squared is 2, or 320. So you're
Oh,
just
man, bro.
I just So 392 breaks down into what? 196. 196 and 2. Remember that my microphone picks up everything. So if you're telling stories off to the side, all of YouTube will know. 196, the square root of 196 is 14. Okay. 3/4 times 14, what's that?
10 to the half.
What?
Well, I just
What?
21 over 2.
Thank you.
Just gave you the mixed fraction.
I don't know. I don't even fraction it.
21 over 2 and root 2.
Yeah.
You're going to try the try.
I didn't.
This one we're going to get square root what?
81x12.
81x12. The 81 can come out as a 9. And the x squared, or x12 can come out as an x. 6 comes out as holy schmoberdiddles, the square root sign goes away. So they're both perfect squares.
I did. I just did it.
Okay. Task 2. Square root of 81 is 9. The square root of x12 is x6. They're both perfect squares, so there is no square root. Nothing got left behind. Task 2. Simplify each expression. This requires some distribution. Identify the restrictions on the variable when necessary. So, let's multiply. Paying attention. Root 2 times root 2 is?
2.
2. Root 6 times root 6 is?
6.
6. Root 8 times root 8 is
9.
8. Root A times root A is
Joke.
A. Root smiley face times root smiley face is smiley face. I repeat, root 2 times root 2 is 2. The square root symbol just goes away, right? Okay. So we're going to multiply these ones. We're going to distribute them first. So we do coefficient times coefficient, radicand times radicand. 1 times 2 is 2. So I put an equal sign. And I go 1 times 2 is 2. Root 10 times root 10 is 10 in brackets. Because you have to multiply these two numbers. So remember, when you multiply two radicals that are the same, the radical sign goes away. Because root 10 times root 10 is root 100, which is 10. Root 10 times root 10 is root 100, which is 10. Then we have to do the next one. Plus sign. 1 times root 5, 1 times 1 is 1. Do I have to write the 1? No, I'm writing it for point. Root 10 times root 5 is root 50. Then we have to simplify. 2 times 10 is 20. Plus, what can root 50 break down into? 25 and 2. The 25 comes out and it is a 5. So it equals 20 plus 5 root 2. Box it.
Oh, lost.
Yeah.
So you don't add the 25.
No, because they're not like terms. We learned that yesterday. You can only add radicals that are the same. So I can only add root 2s to root 2s and numbers to numbers, which you can't do.
Okay.
Yeah, literally just 10. So that's fine.
Root 10 times root 10 is square root of 100. What's the square root of 100? 10. Done.
It's literally like square rooting it and then just doing the exact same back.
Yeah.
Yeah.
Are you sure? Nope, we're going to work on it. Okay. So, this one we're going to go together on too, and then you're going to try the next two. So paying attention. Coefficient times coefficient. 1 times 3 is 3. Then root 15 times root 5 is root 75. Then we distribute the next one. 1 times negative 1 is negative 1. Then root 15 times root 3 is root 45. So it's coefficient times coefficient, radicand times radicand. And then we reduce them. 75, what does it break down into? 25 and 3. And when the 25 comes out, it's a 5. Minus 145, does it break down into anything?
Yeah.
9 and 5. When the 9 comes out, it becomes a 3. And you multiply the numbers in front. This is why radicals are so important in grade 10, because the little we're doing right now is mainly grade 11, or the top is grade 11, mainly we're doing grade 10 after. Oh my gosh, I can't even speak. Yep. Because root 10 times root 10 is 10. When you multiply two radicals together that are the same, you get the answer without a radical. Like root 5 times root 5 would equal 5. So because these two are the same is the only reason why. So here we're going to get 3 times 5, which is 15, root 3, minus 1 times 3, which is 3, root 5. And now we have to use what we learned from yesterday with adding and subtracting. We can only add and subtract radicals that have like radicands. This one is a square root 3. This one is a square root 5. Are they anything alike? Are they alike? No, not a trick question. Root 5, root 3, not the same. You are done. You can't put them together. You can only put together with addition and subtraction like radicands. They are not alike. Okay? You're going to try B and the try. Watch with the try. You're going to have a root x times a root x, which is just going to get us a x. Exactly. So we are going to go 2 root 2 times 1. So I do coefficient times coefficient, radicand times radicand. There is no other radicand, that's fine. So I'm going to get 2 times 1 is 2. Root 2 times nothing is root 2. Also, if you think about it, anything times 1 is what? Itself. So 8 times 1 is 8. 10 times 1 is 10. 1 million times 1 is 1 million. So 2 root 2 times 1 is 2 root 2. Then we go to the next one. 2 times what's in front of it, which is a 1. 2 times 1 is positive 2. Root 2 times root 2 is 2 in brackets. So whenever you do a square root times a square root, you get the same answer. You just put it in brackets. So now I'm going to get 2 root 2 plus 4. Can I put anything together? I have something with a root 2. I have something without a root 2. Can I put them together? No, they're not like terms. Remember yesterday's lesson? You can only put together square roots that have the same radicand or numbers that don't have a radicand. So I'm done. Now the next one. We do 3 times 2 with an equal sign. Make sure you have equal signs running down your whole left-hand sides because people will have no equal signs. You just have math floating on your page. So 3 times 2 is 6. Root x times root x is x. Then 3 times negative 1 is negative 3. Root x times root 2 is root 2x. Can anything change on that root 2x? No. So I have 6x and then a root 2x. Can I put them together? Are they like terms? No. I done. I box. I move on. Most people do these terribly, not because they can't get to this point. It's because they're like, must look better. So you like put stuff together that can't go together and then it goes all, it's like, yes, good, yes, good, yes, good. Stop, stop, why are you still going? What? 2. I'm like, I don't even know how that happened. So, please stop. All right. Oh, we have a binomial times a binomial. Yes? Yes, you do. Thank you. You need x is greater than or equal to 0 because there's an x under the radical. You are the best on my list. It's a good list. I'm making 2 lists now. I won't tell anyone what list you're on. I'm just going to say you're on a list, and then you can figure out which list you hit. Okay? Okay. All right. So, binomial times a binomial. Your teacher would have given you an acronym to help you out with this. Binomial times a binomial. Foiling. F-O-I-L. So you do the first part, then the outside ones, then the inside ones, then the last ones. First, outside, inside, last. Say you're like, I don't like acronyms, Lepp. Not my thing. All you need to know is you need to multiply everything in the one bracket by everything in the other. Okay? So as long as you do that, that's fine. So I'm going to FOIL them. So first times first. I get an equal sign because it's going to equal. This is where we're going to get more like terms to collect. Okay. 3 times 5 is 15, and then we just get root 7 because there's no other root to multiply by it, correct? Then we go to outside. So we do the first terms together, then we do the outside terms together. 3 times 2 is 6. That's from grade 2.
Thank you.
3, possibly. And then insides. 4 times 5 is 20. Root 7 times root 7 turns into 7 in brackets. It should be part of your life. Root 7 times root 7 is 7 in brackets. Root 7 times root 7 is 7 in brackets. Okay. And then last terms. 4 times 2 is 8. And then root 7 times nothing is root 7. So let's simplify some stuff here. So we get 15 root 7 plus 6 plus 20 times 7 is 140 plus 8 root 7. Am I done?
No.
No, I actually have yesterday's, this would be like a yesterday's question. So, 15 root 7 and 8 root 7 are like terms. They're asking me to add them. So what do I get? 23 root 7. And then I have 6 plus 140 is plus 146. Box that baby, be proud of it. So smart. Okay? I want you to try the next 2. Go. All right, so we're going to go first times first. So we go 1 times 3, which is 3. And then outside times outside. 1 times root 3 is root 3, or 1 root 3. Inside, 3 times root 3 is 3 root 3. And then last, root 3 times root 3 is 3. You could go 3 in brackets, but it's not multiplied by anything, so it doesn't matter. Then we have to collect like terms. 1 root 3 plus 3 root 3s gets me 4 root 3s. Thanks for the answer.
You're welcome.
And then 3 plus 3 is 6. Yeah. Done. Okay. Then we're going to do B. 1 times 1.
When did that turn into 4?
Right here.
I don't know why.
1 root 3 plus 3 root 3s is 4 root 3s. Okay. 1 times 1 is 1. 1 times negative 5 root 2 is negative 5 root 2. 1 times positive 5 root 2 is positive 5 root 2. And then last terms. 5 times negative 5 is negative 25. Root 2 times root 2 is 2 in brackets. So now I get 1 minus 5 root 2 plus 5 root 2 minus 50. And then I got to collect my terms. So negative 5 root 2 plus 5 root 2s is how many root 2s? None. They go away. 1 minus 50 is negative 49.
Yes.
The negative 5 root 2 plus 5 root 2s cancel.
Yup.
Yep.
Yup.
Yeah.
Yup.
Yeah. Okay,
Read me
so
that now.
zip it, child. All right. So what I want you to practice for tomorrow are these. Don't stamp your hand like you didn't see homework coming. Seriously. Page 289. I want you to practice these because we're going to get into harder examples tomorrow.
Oh.
You picked the wrong class, child. That's what you want. Numbers 2AB. Yeah, but I'm a rebel. I'm writing it here. You see? 2AB. Rebel without a cause, Carson. That's me. And then number 4.
Yup.
ABC. Glad I can't hear you. Safer that way. And then,
The mic probably picked it up.
probably, I'm not going to listen
I
to
don't
it.
want to.
And then number 6, AB. I'm not picking all the ones that were at the bottom of this assignment because we did not get through all the harder questions. So you can't do the entire assignment.
Good.
So do those.
This is way less.